Okay, hello everyone. I hope that you're doing well. This is an overview on the book Smart Device to Smart Device Communication. The idea of this video is to provide an overview of the book. This is not a tutorial, it's not a survey on D2D. Now, mainly we want to discuss the content of the book, which are the main characteristics of D2D that are addressed in the book, and also the challenges that each one of the chapters is presenting, and obviously just to give a general idea of which kind of applications and services and open issues we have for D2D. So you can see that the book, this is the structure of the book, and the book comprises 10 different chapters, and we can say that the book itself is a collection of results for different aspects of D2D. And if you read each one of the titles of these chapters, you can see that this is not a survey of D2D, but it represents a self-contained chapter that address a particular problem. Okay, so if you're interested in the topic of each one of the chapters, it's better for you to check the names of the authors and just Google their work. Okay, let's move on. Chapter number 1, it's in the introduction. It's just to talk about what D2D communications are, and I will take some time in this chapter just to give some of the main characteristics, and then we can move faster in the next chapters. So the idea here is that if we have two devices that are in proximity, where proximity can mean not just physical proximity, but some characteristics in terms of SNR or load or any other parameter that we can measure from these two devices, we can use their interface. So we're assuming that we have devices with several wireless interfaces. They can have a Wi-Fi or LTE for sure, and then we have these two devices that are supported in the LTE network, and if they are in this proximity region, that means that they can have a communication. So the idea here is that if we have these devices in proximity and they have content to share to each other, then we can take the control information handled by LTE network, but the data plane or the content can be actually handled or hand over from the InnoV to the devices themselves. So we can have this in coverage in terms of control. In the control place in coverage, the InnoV knows these two guys, but the data is actually handled by them, or the data transmission. So that is what we want to do, and the way to do it is a challenge for these kind of proximity services. We can say that this is designed to improve the efficiency of the network, because if we have these devices in proximity, they can improve their data rates, or the power consumption can be reduced, and of course things like latency and the load handled by the InnoV or by the base station in the LTE network can be actually reduced. So here we have 4 different scenarios that I want to talk about, and is to answer these questions: where and how D2D can be implemented. So the first scenario is the basic configuration for device to device. So we assume that we have the base station, and we have the control plane that is handled by the network, by the cellular network, and the data is actually handled by the devices, right? So we can have some ranges of this possible communication, and that's it. They can transmit information in proximity, and there are some other services that I will mention in the next slides. So this is the first one. The second one is when we have devices, some of them may be in coverage, so that means that they are within the coverage of the cellular network, and some of those devices that are in the proximity of this one may be out of coverage. So if this guy is out of coverage but has the capacity to talk with this guy who is in coverage, then the out of coverage device can just use this one as a relay. So we can have this new usage of the devices just relating here, and we can basically converting the cellular network in a multi-hop or something like that. So this is another application that we can have. A third application that is also described in the book is when we have different devices and all of them will receive similar content, or they want to access similar content from the base station. Or let's say, for example, we are in a stadium and the base station wants to deliver some video or some advertisement. So what is better to do here is to just select some of them, and the base station is going to select some of them and transmit the data to them, and they are going to create this formation or this mobile cloud, how is defined in the book, and they are going to just share the resources. So they are going to share the packets and they are going to share all the content that they are receiving. And the fourth application that we can see here is that we continue having the control plane handled by the InnoV, but the communication is actually happening here over this Wi-Fi infrastructure. So that means that we are using the spectrum not of the cellular network but the spectrum of the Wi-Fi bands. So that means that we can actually change this radically, because we are offloading the InnoV, not just sending information directly between devices, but also they are being carried over different frequencies, over unlicensed bands, we can say. So interesting thing here to say is that device to device is known or defined by 3GPP as proximity services. So the idea here is that we want to perform different tasks, and 3GPP has two different groups devoted to develop these two main tasks. The first one is the discovery process, and mainly it can be restricted or can be open. So restricted is when we have this tight control by the cellular network, or when it's open is when the devices they need to perform the discovery themselves. And of course, these proximity services, as I said before, is just based on the physical proximity, but also other parameters, the SNR, the delay, the density, or the load that they have in the network. And of course, once that we have discovered the devices in the proximity, we need to actually do the communication. These are the two tasks developed for 3GPP groups. And we have another group that is related with these proximity services that is working for the IEEE 802.11, and this group is for attempting to provide also services in the same line. So here I'm just trying to emphasize the fact that this device-to-device communication is also a nice way to see how LTE and Wi-Fi can eventually converge, and just to make this completely transparent for the users and just improve and increase the coverage and services of the users. So the applications that we're expecting to see is mainly in public safety and security services. So let's say that we have different let's say the office, the police department, and they need to communicate with each other, and some of the policemen are out of coverage. So they can use these proximity services as and they can use their smartphones or the devices as walkie-talkies, for example. So the idea here is that if we have these standardized public safety and security services, we can initially use D2D for these purposes. But there are many other applications. Now there are some discussions in the book that they say, like, well, we can use this for machine to machine, or vehicle to vehicle, or in general just peer-to-peer communication. So we can have devices, and your device can talk with this not only another smartphone, let's say, but you can talk with robots, or you can talk with cars, and you can somehow integrate this idea, this concept, which is kind of related with Internet of Things as well, but this is just focused in the application on the adaptation of LTE resources. We can have also content distribution. And as I said, if we have this video or advertisement, something that should be broadcast or multicast there, well, we can use device to device. The idea here is that we can use cellular offloading. Now we take the load of the network and just handle that to the device-to-device links. We can use them as relays as well, and we can have so many other applications. But the initial ones is public safety and security services. Now, there's something interesting that if you go to the literature and try to find out what kind of studies they are doing nowadays, you can find that there are two flavors for the way that they are managing the spectrum. So the first one, and is the most important one, because we want to have operators using the LTE networks, they want to be in control of the spectrum, and that is called in-band. So when we are just using the cellular network resources, we can say that it's an in-band communication, and we have two different options in this case, general options, let's say. So the first one is when we have the device-to-device coexisting with the cellular connection. So both of them are in the same band. So they have the same spectrum. That means that, let's say that these two users here have the device-to-device link, and they are transmitting, and this cellular user here is also using exactly the same cellular spectrum. In this case, we have interference coming from these two users to this cellular network user, but somehow the NOV or the base station can handle the interference and can talk to these guys and control the power that they are using, or can just increase the power for this user as well. So there are some techniques that can be applied or maybe applied here in this scenario. So underlay means that we have interference, and in the literature, if you check what happens when you have interference, well, this gives a lot of scenarios that are analyzed using this information theory approach, right? Because when we're analyzing systems with interference, that means that we can apply different things. We can estimate the performance that we will have in the system. You will have a special distribution of nodes and base stations and some geometry in the network. What would be the maximum capacity or maximal throughput if we have this interference? On the other hand, we have an overlay approach, and this means that when we have this cloud of device-to-device users and this cellular user, we don't want them to interfere with each other. So we use the resources of the network, and part of the resources are allocated to these users, and some other parts are allocated to this cellular network. So in this case, this chunk of cellular spectrum is just for D2D, and the other chunk is just for cellular. So in this case, it's way more practical, because if you consider, I will mention this in the next slides, but if you consider just part of the resource blocks for D2D or for cellular, it's way easier to control interference. You don't need to worry about these kind of scenarios, and this is way more easier for practical implementation. So this is like happily the way that the people developing the standard are thinking about this. The usage of out of band is also very interesting, because that means that we can have a control plane also handled by the base station, but the communication is actually occurring in an ISM spectrum. That means that, for example, we can have these devices here. They are controlled by the NOV, but the communication is actually occurring in some Wi-Fi band, for instance. So the problems here is that we can interfere with devices that are operating in the Wi-Fi spectrum, and we can also receive interference from them. So here is way more challenging scenario, but still something that the book is presenting as a possibility in the future. Okay, having said that, we can just go to chapter number 2. And here the chapter describes in a very high level how different components in the LTE network would interact with device to device. So they start by this general description of the subsystems of LTE. That means that the U-Tran, the access network, or the evolved packet core, and when we have this everything in IP, and they just mention several scenarios defined by 3GPP and which are the possible standardized addresses. I need to say that some of the information is repeated chapter after chapter, but it is okay because they may tell you information that the others are not telling you anyway. And of course, if we want to have this kind of services for LTE-Advanced, they discuss, well, what could be the best strategy that we can implement for this D2D at the access network. So they have a list of enhancements they are proposing and how this can modify the architecture of the access network. And I think that the most important aspect that they discuss here is that resource allocation and power control are very important, and they are very important because they are thinking that they are going to reuse the same frequencies for the cellular network and for the device-to-device communication. So in this case, we have interference, and when we have interference, efficient power control makes sense. If we have isolated bands for the D2D and for the cellular communications, then we just want to know what is the best way to perform the resource allocation for the both communications that we have. They have some results. They have these simulations. They perform a discovery process for the devices. And of course, the takeaway lesson from this chapter is that when we invest resources in the discovery process, we are going to degrade the performance of the cellular network, and it makes sense. We need to take part of the resources of the cellular network and allocate those resources for the device-to-device communication. So we need to find a balance between the throughput and the spectrum reuse that we have when we want to implement this D2D communication. And they have also some discussions about traffic load and how we can just reduce the load at the cellular network. Okay, chapter number 3 is about mode selection. Mainly, they have this interesting discussion about mode selection. And mode selection means that when we have, we can explain it. Well, we explained it before, but when we have this network and we want to share the resources, or we want to just allocate resources specifically for the users and not have interference with this one, so we have different flavors here. And when we are doing the discovery phase, and when we are doing mainly the discovery phase, we can have these two approaches. First approach is an independent of infrastructure. That means that the NOV is not related with the devices, so they just find each other, like if we were in an ad hoc network or a MANET, so they can find each other and they don't need any support. Or we can have the network assisted discovery. That means that this NOV knows both of the guys. One of the guys has content to deliver to the second one and just send that information to the NOV. I have this information. I am a D2D device. Is my target, or my target device available? And the NOV is going to coordinate that thing. And that is, of course, way more efficient in terms of signaling and cost, but should be handled by the NOV. So here the discussion, as I said, is what is the best way to change between the overlay, underlay, or just not going for device to device, just doing the normal approach, just transmitting directly in the cellular network as defined in LTE. And they have this mode selection, and they say that, well, we can actually perform this dynamic change of mode if we take into account statistical information. So they think that, well, let's consider some measurements over time of our distances or the interference or the SNR, and we can take that information, and based on that we can just change the mode of the transmission of the spectral resource allocation. And of course they have some brief discussion about quality of service and what is the impact of modeling the traffic as an infinite backlog model, or if we have bursty traffic, and what is the performance of the system in these scenarios. They have this discussion at the end of the chapter as well. Chapter 4, interference management, and here we want to answer, in this chapter, we want to answer how to manage interference, right? And why and where interference between the D2D and the cellular network appears. So let's say that, let's use this figure, and we can have this device-to-device cloud here. These two devices are transmitting, and we can have the downlink for the cellular user. Right, so when we have the downlink of the cellular user and the base station knows these two guys because they are in coverage, that means that the base station somehow can tell the guys, hey, reduce your power because I have a user, a cellular user in the proximity of your communication, and is being interfered. So somehow the InnoV can regulate that. On the other hand, when we are thinking about the uplink, the problem is kind of big, because this user here may be in the proximity of this D2D communication, but is not really aware that this communication is happening. So it's potentially interfering here, or maybe just destroying the communication here. And also, if this user is sending information to the InnoV and these two devices are very close to the InnoV, they can also destroy the communication if they are accessing exactly the same resources in the uplink of this user. So the idea here is that, and why is more important the uplink? Well, in the literature you can find that the uplink bands are less utilized. So that means that it's more likely that if we use the uplink bands, we interfere less and we have more spectral reuse. Right, so we can use those frequencies, and in terms of hardware, is also more efficient because it implies less modification to the structure of the devices in the RF chain of the devices. So here is basically the idea. And so we will be facing something like this, which is the main problem. And here, of course, we can have like different scenarios, especially underlay mode. So when this cellular network and the D2D are sharing exactly the same spectrum. Now, we want to have this quality of service for the cellular network users, right? So if we have that constraint in the system, we need to restrict the interference from the D2D cloud. So that is something important that can be handled by the base station if the base station knows the users in D2D whenever they are in coverage. Right, so we have also to enhance the performance of the D2D, and the idea here is that, well, we can use the information that we have at the base station. So if we are going to receive a lot of interference, the base station somehow can help the D2D devices, somehow isolating them or allocating special resources for them. There is another approach when you don't need to have the interaction with the base station, and in that case, that means that the receivers have these capabilities to perform these receive techniques and to mitigate interference. In that case, we don't need any help from the base station. But there are different flavors, and this is just very general what could be done here. This chapter, I think, that is closing with this discussion about D2D interacting with small cells. So that means that we have a complete heterogeneous network. We have the cellular network, we have small cell, picocells, and we have also the device-to-device links there. Everything is happening in the same area. So we will have for sure co-tier and cross-tier interference. So this is one of the issues that obviously can appear here. And the idea is like all these open problems about signaling and about resource allocation should be address for every particular scenario, and then just come up with a global solution. Chapter number 5 is obviously how we do this establishment and maintenance of the D2D communications. And here there are two approaches that are discussed. When we have devices in coverage, that means that the base station is coordinating the D2D transmissions. We can assign resources in a very particular way so that there is no interference. For instance, here we have these LTE signals that are transmitted in the frequency time plane here, and we have these discovery beacons that are just devoted completely for the devices, so they can find each other, they can communicate with the base station, and so on. So that is dedicating resources. In this case, we don't have any problem in terms of interference or signal controlling, because everything is just managed by the base station. And we have many approaches here. This chapter is going to talk about different configurations of this resource allocation and how can be used to cancel out interference. On the other hand, if we are out of coverage, if the devices cannot talk to the base station directly, but they can talk to each other, well, they can do a random access approach, right? So that means that they need to, they have this collision domain that they need to handle. They need to do this ready to send, clear to send. All this handshake process should be done. And of course, they need to handle also the retransmission, the error correction, and things like that. And somehow, it's like the question here is like, in which situation, in coverage or out of coverage, how the devices should handle these problems. So this chapter is just about that. Chapter number 6 is about network assisted D2D. So as I said before, when we have this network assisted, that means that we always have the cellular network in control of how the resources are allocated. So basically here we have initial discussion in the chapter about the security and public safety. They talk about some progress of this kind of services in the US and in Europe as well, and some discussion about the discovery processes, all the techniques that we can have. And the idea here is that we have LTE already working. The structure is pretty stable. We have the several releases and so on. So the idea is like to reuse the features developed for LTE and adapt them to D2D communication. So basically they have the same signal structure but with different names, but it's basically the same channels for transmission and control, right? Of course, we have different alternatives for discovery, and here this chapter is saying that, well, we can use information that we have before or after the communication, and if we use this information that we have related to each one of the devices that want to do D2D, then we can use that thing, or we can go just by allocating resources specifically for the discovery process using this beacon, the beacons here. We have also some problems here, and probably most interesting here, the issue that is more interesting here is that the synchronization part, when we have this, or when we have FDD or TDD, and how this is affecting also synchronization. And for sure we must guarantee synchronization to improve the efficiency and the resource allocation and the power allocation as well. And here we have also some discussion about how the architecture of the access network in LTE should be modified to support some of these features in this chapter. There are some, well, this chapter presents many figures, many possible scenarios, and the idea here is that when we can have or assisted or not assisted communication for D2D. And obviously when we have assisted, that means that we are in coverage. So we have the INOV and the control plane is handled by the base station. When we have no assistance, well, maybe it's because we are out of coverage, right? So let's say that we are in a disaster scenario where somehow the base station is just stop working. It could be anything, not any natural disaster, let's say, and then we don't have access to the Innovate. So what would be the best way to perform this D2D? For instance, this could be like a good scenario for a walkie-talkie type of service here, and we can use just the LTE bands to hold this this kind of communication. And we need to say that there is always interference coming from other sources that we cannot control. Like that is the intercell interference, right? So we always will have this, and when we are using also the out-of-band approach, we will have, of course, interference coming from the other systems. Chapter number 7 is also very interesting. Let's say that this chapter is just hacking the stack here, because they hack actually the encapsulation, so they can take all the load from the cellular network and just hand over it to the Wi-Fi infrastructure. It's very interesting how they modify the package, how they change the headers and things like that. So they are very technical in that aspect. So it's a broad and very deep material here, and basically they discuss initially about the different entities in the network that should be there to support the D2D communication. So they say like the EPC should have like these D2D services, and somehow these D2D services should manage the access to the application services that are in internet. And once that you have defined those things, you can actually offload the traffic from the InnoV to the Wi-Fi bands, and you need to have the Wi-Fi infrastructure. So in this case, you are using actually the two wireless interfaces that you have in the device. You are using the LTE wireless interface and the Wi-Fi interface. So in this case, it's efficient the way that we are using the components or the technology that we have in the devices. And of course that reduce the load in the cellular network. So very interesting. I think that is one of the most interesting chapters, at least for me, and you can go and check it out. Chapter number 8 is going to have this discussion about heterogeneous networks. As we said before, we can have interference with the small cells, but we can also have small cells providing the D2D services, and services in the sense that they handle the control plane. So in this case, like in this figure, we have these users here that are coordinated using the base station, or these users here that can support their proximity services supported by this picocell here. This is discussed in this chapter, what kind of architecture we can have, how this should be modified, which features we have if we implement these small cells or picocells in this heterogeneous network. And there is another analysis here, because the author said like, well, now let's think that what is the power, what is the implication of having all this communication and the signaling here, what is the impact over the backhaul power consumption. So they have this analysis in terms of backhaul energy efficiency as well. So that is the content of chapter number 8. Chapter number 9 is going to introduce a concept that is called mobile clouds, right? And they have this nice discussion about the resource sharing. So the idea here is that, as I said before, is the InnoV or base station has some information to transmit here, and what is the best way for them to find each other? So how one device can find another one who wants to cloud, who wants to share resources, but because in this case, let's say, for example, that this device has some information transmitted from the InnoV and transmit that to this guy here. And then this guy is going to perform some processing to that information and send that information back to the base station through this guy. So in that case, we're using this resource sharing concept in which the mobile cloud is not just to deliver information, but also the devices in proximity can actually exchange information, process information, and share that processed information among each other. So this is very nice idea, and of course it's just the conceptual idea, because it's just very descriptive, the chapter, how this could be implemented and things like that. And of course we have this description of what the things that we need to create this mobile cloud, so we can have the formation, the operation, and how we actually maintain the cloud operating. Finally, chapter number 10 is a discussion about smart grid. This chapter is not really focused on discussing how smart grid and D2D are interconnected, but it's going to tell you something about smart grid and LTE. So when you have this integration of smart grid and LTE, eventually that is going to be touching the device-to-device technology as well. So this is just the way that the chapter is organized. We have this introduction to smart grid, which are the kind of services that we can support, for instance automation, and how critical is this kind of infrastructure that we have for different kind of services, the integration with LTE, and probably the integration with machine-to-machine communication. And they have finally one study of commercial cellular networks integrated with smart grid using real measurements, which is quite interesting as well. So just to finish this short presentation, I want to point to 3 different resources that you can use, these nice references that can give you a broader idea of D2D communications. So the first one is this paper, a survey on device-to-device communication in cellular networks. Is from 2014, and you have this structure. You have this classification, underlay in-bands, overlay in-bands, and so on. And for me, the most important thing is here they have this overview of the proposed protocols for device-to-device. So that means that you can see how research has been applying the specific scenarios for D2D, and how the protocols should be adapted at the MAC layer and physical layer. You have also these 2 references that are related with LTE. The first one, which is all the characteristics that we have in LTE release 12, and they have a very nice description of how D2D is actually implemented in LTE. So you can see how the frames, how the name of the channels, how all the very detailed technical characteristics of LTE are implemented. And this is this white paper by Roden Schwartz. And you have this an overview of 3GPP device-to-device proximity services. This is also a very nice paper. It's also just talking about all the characteristics of device-to-device. Is also a paper that is going to give you some information from academia and also some information from industry, so you can have a more global view of what D2D means. So that's it. I hope that this has been informative for you, and I would like to thank you for viewing.